In this lesson, you're going to learn how to create sensitivity tables for a leveraged buyout model. Now, as we mentioned in the previous lesson, the reason why sensitivity tables are so important for a model like this is because when we have the returns calculation right here, the internal rate of return for a PE firm buying a company, we don't really know what the EBITDA exit multiple is going to be. We don't really know what the purchase multiple is going to be. They could buy the company for a number of different prices. They could sell it for a number of different prices. And then beyond just that, if we go up to the top, they could even use different amounts of debt when buying the company. They could use, for example, different types of debt, different interest rates. The company could even have a different operational profile. So maybe the revenue growth is different, maybe the expenses are different. And so all those variables are going to ultimately impact the rate of return here for the private equity firm. And so rather than just sticking to the one number that we have here, we prefer to look at a range of different values by setting up sensitivity tables to look at variables like the purchase price versus the exit price, or the purchase price versus the amount of debt that they're using. Now the mechanics here in the sensitivity tables will be very similar to what we saw for the merger model, for example, where we looked at purchase price versus synergies, or even the DCF, where we looked at the company's per share value versus the discount rate versus the terminal growth rate and terminal EBITDA multiple. So the mechanics will be very similar, but the input variables here will be a bit different. So to start with, the input variable that we almost always use in an LBO like this, unless we already know the exact purchase price, is the purchase price of the company. So what kind of premium are they paying? What kind of purchase price are they actually paying to acquire Apple here? Since Apple's a public company, we're going to frame everything in terms of a per share price in this case. Now remember, at the top of the model, we had this assumption that they're going to make a premium to Apple's current share price. So we're going to stick with that. And what we're going to say here is that the bottom case here will be a 0% premium. Just up from that, we'll have a 5% premium. And then we'll keep going up by 5% each year here. Now in terms of share prices and what that means for share prices, well, what we can say is 1 plus this premium times the current share price of 192.06. We can just copy this up and see that as we go higher and higher up to almost 50% premium here, the purchase price is gradually going up as well. Now for the exit multiple, so remember here that we assumed 10x for our EBITDA exit multiple. So what we're going to do here is make sure that this 10x is relatively in the middle of our range. So we're going to go from 6x and go up by 1 each year. We see that 10 is right around the middle of our range, so we're going from 6x to 14x. Now this may seem like a very wide range to you, but keep in mind that going back to the public company comparables, for example, well, you also see a very wide range for these EBITDA multiples. You have them going from 4x to 11x, 12x. And so if you look at the comparable companies, you see they're trading at a wide range of values. If you looked at Apple's historical valuation data, you would see that they have traded at a wide range of EBITDA multiples as well. So anything can happen in the span of 5 years, and their exit multiple could even be outside of this range that we have right here. So nothing is impossible when it comes to exit multiples, which is why we want to establish a large range for them in an LBO model like this. The next step here is to link in the IRR number from right here. I'll anchor that. Then to actually make the table, we'll select everything with Shift Control down, right, Alt DT for the data table. Then for the row input cell, we're going to use the EBITDA exit multiple right here. For the column input cell, we're going to use the offer premium right here. I'll press OK. I'm going to hit save to refresh the table. And so we see that, sure enough, as our exit multiple here increases from 6x to 14x, our returns go up significantly. In some cases going from 10 or 11% to 32%, so a huge difference there. And then as our purchase premium goes up, our returns decrease. In this case, it looks like the exit multiple makes more of a difference, but it's actually pretty hard to tell because we're not really comparing apples to apples here because we're looking at share prices and premiums versus multiples. So they're not really the same thing, but these two variables will generally have the biggest impact on an LBO model, which is why we like to use them in sensitivity tables as we have right here. Now for your exercise, what I want you to do is fill in this other table where we look at the return versus the purchase premium and percent debt. So it's very similar. The mechanics here are very similar, except instead of the EBITDA exit multiple, we're going to be using the percent debt instead. So going all the way up to the top, you want to be using this percent debt number in your formula for the sensitivity table. So pause this video right now and try to enter in the sensitivity table yourself using everything we've learned in this course and modeling it after what I just showed you when entering the sensitivity table for the returns for EBITDA exit multiple versus the purchase price. Okay, good. So here's what we can do to set up our table. First off, let's not repeat work that we've already done. So for the purchase price and premiums, I'm just going to link to our table right here directly. I'm going to link them in and then copy this down. Now for the percent debt, remember that we have 50% as our baseline assumption. I didn't give you exact instructions on what to use for this, but one thing that you could do is try to get the 50% to appear right here in the middle column. So to do that, we can start at 30%. We can increment this by 5% in each column, so that we have 50% in the middle and then 70% and 30% at the ends here. Now you could go even lower than this. You might have thought about going to 10% all the way up to 90% and doing 10% increments, but to be honest, that's a little odd. You hardly ever use 90% debt and you hardly ever use 10% debt. It's usually much more in this range, 30% to 70% of the transaction value. For the IRR, once again, we can just actually copy this formula from the first table. And then to actually make the calculation, we just select everything, Shift Control down, right, Alt DT for data table. And then for the row input cell, we want to use the percent debt. For the column input cell, we want to use the offer premium. We'll hit OK. So we'll scroll down there. I'm going to hit Control S to save everything and refresh the tables. And we see that, as expected, as the percent debt in this transaction goes up, our return also goes up, which makes sense because you know that if you use more leverage, you're going to get a higher return. More leverage means you pay less upfront with your own cash, which means you can get more later on. As our purchase premium goes up, then our IRR goes down, dropping from 20% here to around 8%. Overall, it looks like when comparing these two tables, it looks like the EBITDA exit multiple here makes more of a difference than the percent debt, at least for most of the ranges. And that's how it almost always works in models. Most LBO models are the most sensitive by far to the EBITDA exit multiple and also to the purchase price, the purchase multiple in the beginning. They're also sensitive to the percent debt, the types of debt you use, and to the operating assumptions used in the model. But overall, those generally have less of an impact than the purchase multiple or the exit multiple. So that's how we go through and set up sensitivity tables for an LBO model like this. As I just mentioned, other variables that you might look at would be the debt interest rates, the types of debt. You could look at the operating assumptions behind the company, different revenue growth rates, different operating expense profiles. So you could look at a number of different variables, but the ones that we have here are some of the most important ones because they generally have the biggest impact on an LBO model. With that in place now, we really are done with the LBO analysis, at least for the basic version of our model here. Coming up next, we're going to be going through some possible interview questions that you may get on the topic of LBO models. After that, then we'll look at a more advanced version of this model that includes all three statements, multiple different types of debt, and a number of other additions that we did not go through in this one.